Good morning. So today we shall discuss the rectangular components of a vector. We are going to study the rectangular components of a vector in a plane and in the space. Suppose we have this xy plane, and in this xy plane we have this vector a bar. Now in order to express the given vector a bar in terms of its rectangular components, what we need to do is we have to draw the projection from the end point of the vector a bar on the x-axis and on the y-axis. These projections intersect the x and y-axis at these points. So we consider that this is the x component of the vector a bar and this is the y component of the vector a bar. Let us represent the x component of vector a bar as ax bar and the y component of vector a bar as ay bar. Now, as this is the vector ay bar, similarly this side of this triangle is also equal and parallel to ay bar, so we can consider as if this is the vector ay bar also. So that in accordance with the triangle law of vector addition, which we are going to study next, you must have studied it earlier, that the vector a bar here can be expressed as the sum of the two vectors ax bar and ay bar. So a bar is expressed as ax bar plus ay bar. So this is how we can express the given vector a bar in terms of its rectangular components. So ax bar and ay bar here are said to be the rectangular components of the given vector a bar. Now these components ax bar and ay bar also can be expressed in terms of the unit vectors along the x-axis and y-axis. As we know that I cap is the unit vector along the positive direction of x-axis and j cap is the unit vector along positive direction of y-axis. The components ax bar can be expressed as I cap into ax and the component ay bar can be expressed as j cap into ay. So this component ax bar of the vector a bar along x direction or x axis is expressed as I cap ax, where ax is the magnitude of the component of vector a bar along x axis and I cap is the unit vector along the positive direction of x axis. Similarly, ay here is the magnitude of the vector ay bar and j bar or j cap is the unit vector along the positive direction of y axis. So the vector ay bar is expressed as j cap ay. So using these expressions for ax bar and ay bar here, we can express the vector a bar as a bar is equal to I cap ax plus j cap ay. And this is how we can express the given vector a bar in terms of its rectangular components, where I cap and j cap are the unit vectors along the positive directions of x and y axis respectively. Ax is the magnitude of the component of a bar along x axis and ay is the magnitude of the component of a bar along y axis. So this is how we can express the vector a bar in terms of its rectangular components. Now In terms of the magnitudes of the components of the vector A bar along x and y axis, the magnitude of the vector A bar can be expressed as magnitude of the vector A bar is expressed as under root of ax square plus ay square. This is in accordance with the Pythagoras theorem. This is in accordance with the Pythagoras theorem. So, if we consider mod A bar is the magnitude of vector A bar, mod ax bar is the magnitude of the component ax bar, and mod ay bar is the magnitude of the component ay bar, then in accordance with the Pythagoras theorem, mod A bar square is equal to mod ax bar square plus mod ay bar square. So, which gives modulus of A bar is equal to under root of ax square plus ay square. And if we consider theta is the angle subtended by the vector A bar with the positive direction of x axis, then the value of theta is obtained by using the expression tan theta is equal to ay upon ax, and this gives theta is equal to tan inverse of ay by ax. So, knowing the given vector A bar, if we can express, if it is expressed in terms of its rectangular components, then knowing the magnitudes ax and ay, we can obtain the magnitude of the vector A bar and the angle theta subtended by this vector A bar with the positive direction of x axis by using this relation. So that is how we can express the given vector A bar in terms of its rectangular components in a plane, in xy plane, rather you can say. Now let us see how to express the given vector in the space in terms of its rectangular components in the space. This is in 2 dimension. So let us see how to express it in 3 dimensions. That is in space. If we have the 3 mutually perpendicular axes x, y, z like this is the origin, this is say x axis, this is y axis, and this is z axis, and we have a vector A bar like this. This is the vector A bar. In order to express this vector A bar in terms of its rectangular components, what to do? So for that purpose, what we need to do is, we have to draw the projection from the end point of vector A bar in the xy plane first. Suppose this is the projection drawn from the end point of vector A bar and the xy plane. Suppose this projection intersect the xy plane at this point, then we can draw the lines parallel to y axis and parallel to x axis like this. So this side will give us the x component of vector A bar. This side will give us the y component of vector A bar, and if we draw the projection from the end point of A bar on z axis, this side will give us the z component of vector A bar. So the vector A bar here is expressed in terms of its rectangular components ax bar, ay bar and az bar. So, how to obtain this resultant? So, this is the resultant. This is the vector ax bar plus ay bar. So, this can be obtained by using this triangle law of vectors. If this is the vector ay bar, this vector also will be equal to ay bar. So, ax bar plus ay bar gives this sum ax bar plus ay bar. And then if we take the sum of ax bar plus ay bar plus az bar, then in accordance with the triangle law of vector addition, it gives the resultant vector a bar. So, we can express the vector a bar as the sum of ax bar plus ay bar plus az bar. So, this is how we can express the given vector a bar in the space in terms of its rectangular components. And as we know that the vectors ax bar is expressed as I cap ax, ay bar is expressed as j cap ay, and az bar is expressed as k cap az, where I, j, k, I cap, j cap, k cap are the unit vectors along the positive directions of x-axis, y-axis and z-axis respectively. Ax, ay and az are the magnitudes of the components of a bar along x direction, y direction and z direction. So, using these expressions for ax bar, ay bar, az bar in the above expression, we can express the vector a bar as I cap ax plus j cap ay plus k cap az. So that the magnitude of this vector a bar in terms of its rectangular components can be expressed as under root of ax square plus ay square plus az square. So that is how we obtain, we express the given vector a bar in the space or in 3 dimensions in terms of its rectangular components. So that is about the rectangular components of a given vector. In the next video, we shall see the resolution of a vector. Just like in the while expressing the rectangular components of a vector, a single vector is expressed as the sum of the 3 components in the space or in plane. The given vector a bar is expressed as the sum of the 2 components in the xy plane, that is ax bar plus ay bar. The resolution of the vector is nothing but how to express the given vector in terms of its rectangular components. So let us see the resolution of vector, and this is nothing but the resolution of a vector. So a single vector is expressed as the sum of the 3 vectors. In vector addition, what we do is the sum of the 2 vectors, the addition of the 2 or 3 vectors results into a single vector. But in the reverse manner, the single vector also can be expressed as the sum of 2 or 3 vectors, and that is called as the resolution of a given vector. So in this way, we can resolve the given vector a bar in terms of its rectangular components, say x component, y component, and if the given vector is considered to be in the space or in 3 dimension, it can be resolved in 3 components, ax, ay and Az. So that is about this rectangular components of a given vector. In the next video, we are going to study the addition and subtraction of the vectors.